So from the A-level past paper sample assessment material 2018, number 2, the first term of a geometric series is 20. So U1 is 20. And the common ratio is 7/8. So R, which is the common ratio in the geometric sequence, is 7/8. The sum to infinity of the series is S infinity. So we call S infinity the sum to infinity in a geometric series. Find the value of S infinity. Now, for this example, we need to look at the formula booklet, and the formula booklet is found here. So S to infinity has this formula, which is given to you using the formula booklet. Therefore, it's equal to the first term over 1 minus R, where the absolute value of R is less than 1, or you can say that R is between -1 and 1. So going back to our example, we use the formula taken from the formula booklet and we replace. Replacing, we will get 20 over 1 minus 7/8, and using algebra, 1 minus 7/8, common denominator is 8, so 8 minus 7, so the answer is 1/8. But we already have a big division bar here, so you change this division bar into multiplication and you flip the 1/8 to get 8/1 in order for us to continue solving, which is equal to 160. In part B, the sum of n terms of the series is Sn. Find to one decimal place the value of S12. So S12 is equal to, also we have to go back and check the formula, and the formula for Sn is this one. So Sn is equal to the first term 1 minus R to the n over 1 minus R. So you take this formula and you use it in your example and you start replacing. S12 is equal to 20, which is the first term, 1 minus 0.875, which is the value of R, to the 12, over 1 minus 0.875, which is the value of R, equals, if you plug in this into your calculator, you would get 127.8. And in part C, find the smallest value of n for which S infinity minus S of n is less than 0.5. In this case here, we need to subtract the answer that we already found, which is 160 for S infinity, minus Sn. So the 160 minus Sn is less than 0.5. We need to prove that. So we don't have n. The value of n is missing, so we have to replace Sn, or we have to find the formula for Sn, which is equal to first term times 1 minus R to the n, which is the unknown, over 1 minus R, and it's less than 0.5 as it's given in the question. In this case here, we start to use algebra. So we have to multiply. Once we have to multiply or expand. So 160 minus 160 into 1 minus 7 over 8 to the n is less than 0.5. Entering the 160 inside, you're going to get 160 minus 160, because minus 160 multiplied by 1 is minus 160, plus you multiply here because minus times minus is plus, 160 times the ratio to the n less than 0.5. You make the subject, which is 0.875 to the n, because it has the unknown on one side, and you take the other numbers to the other side, and you reach this inequality. Now, in order to solve this inequality, we need log, because in order to have n, to find the value of n where n is an exponent, you need to have n as a number or a coefficient. So you log both sides, and then you are going to have, or to use, the exponent law in logs. So n log 0. So if you're going to write it, it's log 0.875 to the n is less than log of 0.5 over 160. So the exponent law takes n and place it here. So n log 0.875 is less than log of 0.5 over 160. Now divide by this log in order to have n on one side and find its answer. But since log of 0.875 is negative, therefore when you divide by it, this order should change. So it's, instead of having it as less, you're going to have to change the order. So n is greater than log of 0.5 over 160 over log of 0.875. Placing this value on your calculator properly, you're going to get n greater than 43.198. And the next, directly after 43.198, the next whole number or integer, it's going to be 44. So n equals 44 is the smallest number or smallest value that that n can take, in order for us, when we subtract Sn from S infinity, we get the answer to be less than 0.5.